Hello and welcome. My name is Brian Chu. I'm a Microsoft technical trainer. I'm here to walk you through the AZ-800 Administering Windows Server Hybrid Core Infrastructure course. Let's get started. In this session, you'll learn how to manage Windows Server file servers, implement storage spaces and storage spaces direct, use data deduplication, configure iSCSI storage, and set up storage replica for high availability. Let's begin by exploring how to manage file servers in Windows Server. File servers are critical for storing, sharing, and protecting data in organizations of all sizes. You'll learn about the different file system types, security features, and management tools available in Windows Server. A file system is a set of features that allow you to store and retrieve files on storage devices. It organizes files in a hierarchical structure and controls their format and naming conventions. Windows Server supports several file system types, including FAT, FAT32, EXFAT, NTFS, and REFS. Each has its own strengths and use cases, from external media to high-performance, resilient data volumes. Let's compare the main file system types. FAT, FAT32, and EXFAT are simple and best for external media like USB drives, but they lack security features and have size limitations. NTFS is the standard for Windows Server, supporting large volumes, file folder permissions, encryption, and compression. REFS is designed for resiliency and large data volumes, offering advanced data protection and support for very large files, but it doesn't support boot volumes or file-level encryption. Choosing the right file system depends on your storage needs, security requirements, and the type of data you're managing. File Server Resource Manager, FSRM, is a powerful tool for managing and classifying data on file servers. With FSRM, you can set quotas to control storage usage, create file screens to block unwanted file types, generate storage reports, classify files for compliance, automate file management tasks, and provide access denied assistance to users. These features help you optimize storage, enforce policies, and improve data governance. The Server Message Block (SMB) protocol is used for network file sharing in Windows environments. SMB 3.x, introduced in Windows Server 2012, brought features like transparent failover, scale-out file servers, encryption, multi-channel support, and direct data transfers. SMB 3.1.1 in Windows Server 2016 added pre-authentication, integrity, and improved encryption. These enhancements make SMB a secure, high-performance protocol for sharing files and supporting applications like Hyper-V and SQL Server. Always consider enabling SMB encryption and use the latest version for maximum security. Volume Shadow Copy Service, VSS, is a Windows feature that creates consistent snapshots or shadow copies of data for backup and restore purpose. VSS coordinates between the following components to ensure reliable backups. First, VSS service. Second, requesters like a backup software. Third, writers such as applications that manage data. And fourth, providers, for example, storage hardware or software. VSS enables you to restore files or entire volumes to a previous state, minimizing data loss and downtime. Next, we'll focus on storage spaces and storage spaces direct. These technologies allow you to create virtualized high-available storage pools using a mix of physical disks. You'll learn how to design, implement, and manage scalable storage solutions for your organization. Storage spaces is a virtualization feature that lets you group physical disks into storage pools. And you can create virtual disks, storage spaces, from those pools. You can then create volumes with specific sizes, drive letters, and file systems. Storage tiers optimize disk usage. Write-back caching improves performance. And you can choose between fixed and thin provisioning. Storage spaces can be managed through Server Manager, PowerShell, or programmatically via WMI. Storage spaces offers scalable, reliable, and cost-effective storage. You can mix different types of disks in the same pool, designate hot spares for automatic repair, and you can also use familiar tools for backup and restore. Storage spaces supports local and remote management, integrates with the failover clusters, and lets you grow storage pools as needed. It's ideal for organizations that need flexible, resilient storage without expensive hardware. There are some limitations to keep in mind. Storage spaces volumes can be used as boot or system volumes, and all drives in a pool must use the same sector size. Storage spaces isn't compatible with pass-through disks, external RAID layers, fiber channel, or iSCSI. For best results, add only unformatted, non-partitioned disks to your storage pools. Storage spaces supports different resiliency types. Measure. It maintains 2 or 3 copies of data for high availability. It is recommended for most workloads. Parity. It uses single or dual parity for sequential workloads, like archives. And finally, simple. There is no redundancy. It is suitable for workloads that don't need resiliency or have their own protection. Choosing the right resiliency type depends on your workload and the protection needs. You can choose between thin and fixed provisioning. Thin provisioning allocates storage as data is written, saving space when growth is uncertain. It is ideal for virtual disks on Hyper-V hosts. Fixed provisioning, on the other hand, reserves the entire capacity upfront. It ensures guaranteed space for critical workloads. Select the provisioning type that matches your storage and business requirements. Storage Spaces Direct is the evolution of storage spaces. It is designed for high-available virtualized storage. It leverages storage spaces, fail-lower clustering, cluster shared volumes, the software storage bus, and SMB 3.x to create shared storage for workloads like virtual machines and SQL Server databases. Storage Spaces Direct supports both direct attached storage and just a bunch of disks, making it suitable for a wide range of deployment scenarios. Storage Spaces Direct builds on several key components. These components work together to provide high-available, suitable storage that can support demanding workloads, like virtual machines and databases. The architecture allows you to pool storage across multiple servers. It makes it easy to expand capacity and improve resilience. Windows Server offers a range of benefits with the Storage Spaces Direct, such as deduplication and compression for REFS volumes, support for persistent memory modules, nest resiliency for two-node clusters, USB flash drive as a witness, and finally, storage class memory support for VMs. When planning your deployment, consider whether you want to separate the virtualization and the storage layers or keep them together. Now, let's focus on data deduplication in Windows Server. Data deduplication is a feature that helps you save storage space by identifying and removing duplicate data within your files. It can work without compromising data integrity. This is especially useful for environments with lots of similar files, such as user documents, software deployment shares, and virtualization libraries. Data duplication works by breaking files into small chunks, identifying duplicates, and storing only unique chunks. This process reduces the amount of storage needed, especially in environments with many similar files, and it helps you get more value from your existing storage infrastructure. The main components of data duplication are the filter driver, which redirects read requests to the correct data chunks, the deduplication service, which manages deduplication, garbage collection, and scrubbing, and finally, an optimization process. It can reverse deduplication if needed. Garbage collection cleans up unused data, while scrubbing checks for data integrity and fixes issues automatically. These three components work together to ensure efficient and reliable storage optimization. Not all files are eligible for deduplication. Files that don't meet the deduplication policy, files in excluded folders, system state files, alternate data streams, encrypted files, files with extended attributes, and files smaller than 32 KB are not deduplicated. This ensures that only appropriate data is optimized, maintaining system performance and reliability. Data deduplication is ideal for several use cases. First, user documents. Home folders and profile redirection can save 30 to 50% of space. Software deployment shares. Storing binaries and updates can save 70 to 80%. Virtualization libraries. Storing virtual hard disks can save up to 95%. And finally, general file shares. Mixed data types can save 50 to 60%. These savings help organizations reduce storage costs and improve efficiency. When considering data duplication, evaluate your workloads. Ideal candidates include folder redirection servers, virtualization libraries, software deployment shares, and backup volumes. Some workloads, like line of business servers or web servers, should be evaluated based on content. Others, like Hyper-V hosts or database volumes, are not ideal. Use the deduplication evaluation tool to estimate potential savings before deploying. Data deduplication works well with other Windows features. It's compatible with branch cache for WAN optimization. It is fully supported in failover clusters. It works with FSRM quotas, and it is compatible with DFS replication. This ensures that you can use data deduplication alongside other storage and file management solutions in your environment. To implement data deduplication, install the role service using Windows Admin Center, Server Manager, or PowerShell. Enable data deduplication on the target volume and configure settings for your scenario. You can exclude specific directories or file types and adjust the schedules for garbage collection and scrubbing. These options let you tailor deduplication to your organization's needs. You can install and enable data deduplication using Windows Admin Center, Server Manager, or PowerShell. Configure settings for static or read-only data. Exclude certain directories or file types, or adjust a peak schedule as needed. Default settings work for most environments, but customization allows you to optimize performance and efficiency. You can run data deduplication jobs on demand using PowerShell. Job types include optimization, data scrubbing, garbage collection, and optimization. Running these jobs as needed helps maintain storage efficiency and data integrity. By default, data deduplication schedules optimization to run every hour, with garbage collection and scrubbing running weekly. You can adjust these schedules to fit your environment. Deduplication also speeds up backup and restore operations, allowing you to backup and restore individual files or full volumes efficiently. Now, let's focus on implementing iSCSI in Windows Server. iSCSI is a storage networking standard. It allows you to connect data storage devices over TCP/IP networks, creating a logical storage area network SAN without specialized hardware. iSCSI stands for Internet Small Computer Systems Interface. It's a TCP/IP-based storage networking standard. It lets you connect storage devices over your network, making remote storage feel like local disks. Its key components include IP network. It uses standard Ethernet and network adapters. iSCSI targets. They are storage resources provided by Windows Server. iSCSI initiators, the client-side component that connects to targets. IQN, iSCSI qualified name. They are unique identifiers for initiators and targets. And finally, ISNS, Internet Storage Name Service. It helps discover and manage iSCSI devices. Let's look at iSCSI functionality in Windows Server. The iSCSI target server role provides authentication, including CHAP and reverse CHAP. iSCSI virtual disks are implemented as VHD or VHDX files. You can manage iSCSI using Server Manager, Windows PowerShell, or System Center Virtual Machine Manager. It scales to 256 iSCSI targets and 512 virtual disks per server. The ISNS role service hosts a database of active iSCSI nodes and supports automatic registration and notifications. This flexibility makes iSCSI a powerful tool for organizations of all sizes. When planning iSCSI, consider these points: network speed, high availability, security, workloads, staff expertise, and application support. Common use cases include diskless boot for servers, storage for server applications, and test labs needing flexible, low-cost storage. To make your iSCSI storage high available, you can use multiple connections per session (MCS). It allows special TCP/IP connections for one session. You can also take advantage of multi-path input-output (MPIO). It lets you use multiple network paths, aggregating devices into a single logical unit. MPIO uses device-specific modules (DSM) to manage third-party SAN devices. This setup ensures that your storage remains accessible even if one network path fails. Now, let's explore Storage Replica, a feature in Windows Server. It enables block-level replication between servers or clusters. It's designed for disaster recovery and high availability. From this slide, we can see that Storage Replica offers many great features that we can use when setting up high availability. Let's compare replication types. Synchronous replication replicates data between sites with low latency, less than 5 milliseconds round trip. It ensures zero data loss. Writes must succeed on both source and destination before confirming. Use this when data integrity is critical. And next, asynchronous replication. It is suitable for longer distances or higher latency. It may result in some data loss, depending on replication lag. The writes are confirmed on the source before being replicated to the destination. Choose the replication type that best fits your organization's needs. Before you set up Storage Replica, you need to ensure the prerequisites listed on this slide are met. Use the Test SR Topology PowerShell commandlet to verify the requirements. Data deduplication is supported, but you can only install and enable on source server only. Remember, you shouldn't enable data deduplication on the destination server. Before you proceed with the implementation, you should first validate that all Storage Replica prerequisites are in place. Use the Test SR Topology commandlet to check configuration. You run it in requirements-only mode first. If successful, rerun it in performance evaluation mode. Review the Test SR Topology report.html file to ensure your configuration meets requirements. To implement Storage Replica, first, in Windows Admin Center, navigate to the source or destination server. Second, use the Storage Replica panel to define a new partnership and reapplication group. Third, complete settings. They include source server, replication group name, destination server, enable synchronous replication, lock size, encryption, and consistency groups. Before implementation, validate prerequisites with Test SR Topology. You run it in requirements-only mode first. If it is successful, rerun in performance evaluation mode. Create a Storage Replica partnership using new SR partnership. Specify source and destination disks, locks, cluster names, and lock size. Next, track replication progress on the source server. You can use get win event to monitor storage replica events. On the destination server, you can review events that describe the creation of the partnership. The next step is to track replication progress on the destination server. You use get SR group and get win event to monitor progress. You can look for event 1237, which indicates replication progress. Remember, there should be no warnings or errors. Let's wrap up our PowerShell implementation of storage replica. To change the direction of replication, use the setSRPartnership command. For example, you can switch the source and destination servers if needed. Note, you cannot change the replication direction during the initial sync, as this could lead to data loss. Now, it's time to put your knowledge into practice. Lab 9 focuses on implementing storage solutions in Windows Server. You'll get practical experience with the features and concepts we discussed. They include storage spaces, data deduplication, iSCSI, and storage spaces direct. In this lab, we will implement storage solutions in Windows Server. First, let's set up data deduplication. We will first launch Server Manager from SCA Admin 1. And from the Server Manager, if we click All Servers, you can see SCA SVR 1, 2, 3. These 3 servers are all online. So these 3 servers are all server core installations. So what we are going to do next is we will add the feature for server 3. So we choose the destination server as server 3. And click Next. And we will find the data deduplication role within File and iSCSI services. So let's expand this one, and we will click Data Deduplication. And then let's click Next to get this one installed on the remote server. Okay, next we will add some file folder sharing in our demo. So let's click All Files and Lab Files. So for the lab files, we will add permission for the remote network access. So what we will do is we will add the permission from the Sharing tab. You can also do that from the Security tab later on. So as we can see here, this one is currently not shared. We will add sharing for all of the users here. So the permission we add is read. Let's click Share. And if we can click the Security tab, you will see that now the users will have access to the folder. This sharing setup is crucial because later on we need to copy the files which will be used in the demos to the remote server. Okay, so let's switch to the server 3. As I mentioned earlier, this one is a server core installation. So we need to run out of the commands in the command line interface. So let's first run the get disk command. There are several virtual disks which are in the offline status. So we will initialize one of the disk number 1. So we will use this command, initialize disk. And after that, we need to create a new partition for this disk. And we also need to assign a drive letter to it. So we will use this command to do that. And the final command that we will run is to do formatting for this M drive. So we will use the file system refs. So after the formatting is completed, next we will copy the files needed for this demonstration to this drive. Remember, we just modified the sharing option for the lab file folders. So here we will use this one to set up a new drive. And then we will create a new item. So we have set up the path as data folder. And then the copy item command. Okay, and then we will use the necessary files to generate some target files which can be used in deduplication scenario. Okay, and then we run the remaining command. So we first set the location as the data folder. And as you can see, there are several newly created files within the data folder. So these files can be deduplicated later on. And let's take a look at the information of the M drive. As you can see now, the free space is estimated 60 gigabyte. So we will take a look at the free space comparison later on after the data deduplication. All right, so this is the preparation work that we need to do for data deduplication. And next, we need to enable and configure data deduplication. So we will switch back to the server manager from SCA admin 1. And let's click File and Storage Services. So let's take a look at the disks on these domain joined servers. And if we scroll down a little bit, you will see that now we have SCA SVR1 with 2 online disks. And we have the M drive with free space of 61 gigabytes. Let's right-click the drive and let's configure data deduplication. So for this one, we choose General Purpose File Server. And for our demo, we will just change it to 0. The next step is to set the deduplication schedule. And here, enable throughput optimization on a daily basis. And click OK. All right, and let's finish the setup. All right, next, we will switch gear to Windows Admin Center. And we will run the deduplication job from here. All right, first let's connect to the remote server, SCA SVR3. All right, so the remote server is successfully added. And from the Windows Admin Center, we can easily run a remote PowerShell command. So let's scroll down a little bit, and we find PowerShell from the Tools menu. So we will start the deduplication job from the PowerShell window. All right. So we will use command to verify the status. You can see that the operation completed successfully. You can get the deduplicated volume right from the PowerShell window in Windows Admin Center. And you can also get the metadata as well. You can see the total chunk storage file size listed here. So the final step for us is that we can get back to our server manager. And here we do a refresh. So you will now see the free space is changed. It has a deduplication rate as 95%. You can take a look at the properties as well. So the savings are 64 GB. Let's cancel this one. And if you want to verify it again, you can also do that right from the SCA SVR3. Remember, we previously run the get PS drive command. We can rerun it. You will see that currently the free space is increased, which means our data deduplication is successful. All right, next, we will switch gear to configure iSCSI storage. Let's first do the remote PowerShell on SCA SVR3. So this is the third remote management method that we will use in our demo. As a Windows administrator, it is really up to you to decide your preferred management tool for the Windows server. And after the login, we will install the iSCSI feature, including the management tools on the remote server. For the previous demo, we initialized disk number 1. So there are still remaining disks which are offline. So this time we will initialize disk number 2 and disk number 3. As previously done, we will create a new partition, assign a new drive letter, and then do the volume formatting. So this is for disk number 2. And we can continue with disk number 3. We will repeat the same process. All set. The final step in our configuration is to open firewall ports for the iSCSI connection. So we will set up 2 new firewall rules for the remote server. Now let's copy and paste the command to see which drive letters are set. Now, let's switch back to Server Manager to take a look at the configurations that we have done on disk 2 and 3. So if we scroll down a little bit, we will see disk 2 and 3 are both online now. So next, we will configure iSCSI. We will click iSCSI tab, and let's start the iSCSI Virtual Disk Wizard. So now, as we can see, the volumes are all listed here. So we will get started with volume E, and we will give the virtual disk name. So we will simply name it iSCSI Disk 1. And for the size, we only consume 5 GB from the free space. And let's click Next. And we will create a new iSCSI target, which later on we will connect to. And we will give it a name. So we will call it iSCSI Farm. And for the access servers, let's add SCA DC1. So we can just browse. And then we type in SCA DC1 and check names. So with this, we can connect from SCA DC1 to this iSCSI target. Let's click OK. All right. Let's click Next. And let's just skip this setup. Click Next. Let's click Create. In product environment, you need to set up the authentication method within this wizard. All set. Let's close this window. And we will switch to SCA DC1 to do the iSCSI connection. So before we do that, we'll create a second iSCSI virtual disk. So this time we will select from volume F. And we call this one iSCSI disk 2. So we will use the same settings as we previously did for disk 1. And as you can see here, there is the existing iSCSI target listed here. So we can just click Next. And create. So if everything works as expected, later on we will find 2 5 GB disks from SCA DC1 after the iSCSI connection. All right, as you can see now, the status is not connected for both of the virtual disks. No worries, we will do the connection. So let's switch to SCA DC1. This is also a server core installation. So let's first start service command to start the iSCSI service. And next, we will do the configuration from DC1. So let's run the command to launch the iSCSI initiator. And for the target, we will select SCA-SVR3. And we click Quick Connect. Remember, we didn't set any authentication method for the connection, so I think login will be successful. And next, we can verify the iSCSI disk configuration from SCA admin 1 server. So this time, let's refresh the server manager. So if we scroll up a little bit, you will see that these two offline disks are all associated with SCA DC1, and they are connected via iSCSI. Since they are in the offline status, what we are going to do next is we will bring them online. So let's switch back to DC1, and we will use the same commands to initiate the disk. So we will assign the drive letter E to the disk. And the final step is to format the volume. All set. After this, we can switch back to the server manager in SCA admin 1 to take a look at whether our configuration is successful. So we do another refresh here. And this time, as you can see, disk number 1 is online, which means our connection to the iSCSI server is successful, and we can use the iSCSI virtual disk. This concludes our session. We've learned how to implement, manage, and secure a variety of Windows Server storage solutions. They include iSCSI, storage spaces, data deduplication, storage spaces direct, and storage replica. You can use them to build reliable, scalable, and high available storage infrastructures for hybrid environments. There are many ways to continue your training journey. We encourage you to watch other videos in this course, or search out your next favorite topic on Microsoft Learn at aka.ms/learn.